Okay, back to our basic sine function here. Now we're going to look at what happens when we add or subtract a number outside the function. So we see that we're adding to subtracting 3. It could look like this where the number's out front. This is the same as adding 4 on this side. So let's see what happens to this. So remember, when we add or subtract, that's going to be a shift this time. So we're going to move the entire graph up or down. So we've got our sine x. Sine x plus 2 should be a shift up by 2. So let's see that. Okay, and we can see that that blue is shifted up by 2. The easiest place to see this is right at the y-axis right here. So see, we were at 0, 0, and now we're starting at 2. And then we go up and down 1 from there. Okay, so we shift up 2 here, and then we go up 1, that takes us to 3. We go down 1, that takes us to 1. Okay, the amplitude didn't change. We just shifted everything up by 2. All right, so sine x minus 3, that should shift us down 3. And we see the green one is shifted down 3, and then we go up 1 and down 1 from there. Okay, period has not changed. We see our complete cycle is still 0 to 2 pi. We're just moving the entire graph up or down. And then this one is 4 plus sine, but again, plus 4 up here, plus 4 back here is the same thing. So this should be a shift up by 4. And we see the orange one is a shift up by 4. So we started at 0, 0, we shift up to here, and then we go through the full cycle from there. Okay, so that's one of the easier ones to see. All right, we shift up and down. It does not change the amplitude. The amplitude still goes up and down 1 from your starting point. Okay, back to our basic sine graph again. Now we're going to look at what happens when we add or subtract numbers on the inside. And numbers on the outside is a shift up or down. Numbers on the inside is a shift left or right. Now you can shift by any amount left or right. I chose some pi increments just because then it's going to be easy to see with our increments here being pi. If you were in degrees, then it would be easiest to see like maybe shifts of 30 or 60. But you can shift by any amount. If this was x plus 1, it would just be a little bit harder to see here. Maybe we'll do that one at the end, okay? All right, so remember, shifts on the outside go up and down. Shifts on the inside go left and right, and they're opposite what you'd expect. So this is a shift pi over 2 to the left. Pi over 2 to the left. So here's our basic period right there, and we're going to take that to the left. Okay, so this is going to go to the left by pi over 2, and then we see the period cycles through like that. So instead of going 0 to 2 pi, we're actually going negative pi over 2 to 3 pi over 2. Everything shifted over by pi over 2 to the left. Amplitude did not change. Our period did not change. We're still a 2 pi period. We're just going negative pi over 2 to 3 pi over 2 now. Okay, so everything just shifted to the left by pi over 2. All right, here we go. Same idea, but this time we're going to shift to the left by pi over 4. Shift left by pi over 4. So picture that in your head. And there it is. So we shift to the left by pi over 4. So we're just shifting one notch on this graph. Shift to here, and we see that the whole thing just scooches over by pi over 4. So we can see the end of our periods went over by pi over 4 as well. Okay. Next one, this is pi over 2, but this one is negative, so remember it's opposite what you'd expect. This is going to go to the right by pi over 2, to the right by pi over 2. So we're going to take this graph, we're going to shift it over to here. So let's see that. So now the orange one, see we shifted to the right by pi over 2, and we've got our period there. So now we're going pi over 2 to 5 pi over 2. Everything shifted to the right by pi over 2. Okay, now when you're just looking at a graph, it's hard to tell exactly what function it came from because some of these shifts end up looking the same because it's periodic. So you can't just look at a graph and know, is this a shift to the left? Is it a shift to the right? You're probably going to have to be given some other information because these graphs can end up looking the same. So let's take the sine x off of there. So for this one, I think this is the one that I want. Okay, so this was our shift to the right by pi over 2. So it starts there, and we've got one full period. Now look what happens with this one. It looks like the same graph, but what we actually did was we shifted this one to the left by 3 pi over 2. So we come to the left by 3 pi over 2, and we get our full rotation by there. But what happens is we shift this to the left 3 pi over 2, we shift this to the right pi over 2, and the period, because it's periodic, they match up. So our purple graph is actually starting here and going around. And then our orange graph, take this one off, our orange graph is starting there and going around. Now there's not really a start and stop because it's periodic, but you see what I mean. Because the shifts add up to one period, they actually look the same. Okay, so again, there's the orange one shifting right pi over 2, and here's the purple one shifting left by 3 pi over 2. They end up looking like the same graph. So sometimes just looking at the graph doesn't really tell you what's going on because they can look similar, and sometimes you can do these shifts and end up with the same graph as something else that's not the same function. Okay, so these graphs are not unique. So let's put them all out there together, and we kind of see a cool mix of sine graphs. You may have seen something that looks like that before with like sound waves and stuff, so it kind of looks cool together, but you can see that they're shifted, at least the blue, the green, and the red, they're shifted by the same increment there. Okay, changing gears a little bit here. We've been doing all of these transformations with sine, but they work the same for cosine. Okay, so we just kind of stuck for one graph to do all of these, but they're going to work the same for cosine. Here's our basic cosine graph. Remember, cosine is a little bit different because it starts at 1, 0, 1. But it's similar in that we've got a period of 2 pi. It's going to cycle through all of our values. We go 1, 0, -1, 0, 1. Okay, so there's our period, 0 to 2 pi. And we have that same kind of S wavy shape. All right, so let's see if we can predict what these transformations are going to do to our cosine graph, because it's going to be similar to what it did to our sine graph. So the 2 out front, 2 cosine x, remember that a 2 out front is going to stretch or compress in the y direction, and this tells us that our amplitude is 2. So instead of going from -1 to +1, we're now going to go from -2 to +2. Okay, so this changes our starting point here, and we still have all the same intercepts, same period, and we repeat from there. Okay, so the number out front, remember that changes your height. Okay, going back to the cosine function, what does the +2 do? Remember, add or subtract outside the function. That's going to shift us up or down, so this should be a shift up by 2. And there it is. Okay, we can see it here. We shift up by 2, and then we cycle through. Okay, so we go back down to this is like our baseline is like right here. So there's our baseline. So we go up 1, down 1, up 1, down 1, and so on. And our period is still 0 to 2 pi. Okay, when we multiply by a number on the inside, remember what that does? That's a stretch or compress in the x direction. And remember, it's opposite what you'd expect. So 2 does not make it bigger, it makes it smaller. It actually chops it in half. So our period is going to become half of what it used to be. Well, those are almost look the same, okay? But we can see it there. You see it's still the same cosine graph. But look, now we fit 2 periods into that 0 to 2 pi. So our period is actually 0 to pi now. There's cosine, cosine, cosine. Okay, so that's what a number on the inside does. All right, now adding or subtracting a number on the inside is a shift left or right, and it's opposite what you'd expect. So this is going to shift us left by pi over 2, left by pi over 2. So let's think about what that's going to do, and here's the picture. We shift left by pi over 2, and then we've got our cosine picture, down and up. Okay, so the green one is our shift left by pi over 2. Here, let me take the original picture off so you can see it. So we start at pi over 2, and we go to 3 pi over 2, because we shifted over by pi over 2. Okay, so there are our examples with the cosine graph. The shifts work exactly the same. You're just starting from a different starting point, okay, different basic graph, but similar in shape and how it works.